Welcome. This podcast is going to focus on balancing chemical equations, and specifically, we're going to provide some examples on how you can count by polyatomic group as you balance. I'm Miss Mixell, and I'm one of the chemistry teachers at Eagle Crest High School, and I hope this podcast is helpful for you. Our EQ for today is to be able to balance chemical equations by counting atoms or polyatomic groups. So just a reminder, when we balance chemical equations, we cannot change the chemical formulas of the reactants or products. Thus, we're never allowed to change the subscripts. Our steps are that we need to create an atom inventory, counting the number of atoms of each element before and after the arrow as reactants and products. Today, as we do this, we're going to keep polyatomic ions together as a group and count them as I have one group of them, two groups of them, and so forth. Then we're going to add coefficients in front of our formulas until both sides are balanced. The atom inventory matches on both sides. So let's look at this first example. I've got iron 3 sulfate reacting with potassium hydroxide to produce potassium sulfate and iron 3 hydroxide. Let's start by creating an atom inventory. And I've already started that for you because I want to point out that we've got iron right here, but sulfate is a polyatomic ion. And so I'm going to keep it in parentheses and say, hey, this is a polyatomic ion. SO4, 1 sulfur and 4 oxygens, is a group of sulfate. And so now when I look at my next formula, I can see KOH. Hopefully you can recognize that OH is hydroxide, and even though there's no parentheses there, that's a polyatomic ion. So if I want, I can sneak in the hidden parentheses, and when we represent a polyatomic ion in a formula without parentheses, that's because there's only one group present, and we don't need to show that one coefficient. So now I can take a second and start to count my elements on both sides of the reaction. On the reactant side, I can see I have 2 iron atoms, and I have 3 sulfate groups. That 3 outside the parentheses represents I have 3 sulfate groups. Remember, when we write a balanced formula, we crisscross those charges to get a net neutral formula. And so we can see that we have 6 valence electrons that iron wants to give away. And so we're going to need to connect these 2 atoms of iron with 3 sulfate groups, each group wanting to gain 2 valence electrons. So when we see the 3 outside the parentheses, we should recognize that as we have 3 groups of sulfate. We have a single potassium atom over here, and we have 1 hydroxide group on the reactant side. On the product side, we have 2 potassium atoms and 1 sulfate group. Again, when I see a polyatomic ion and there's no parentheses there, if I want to cheat and just put that hidden parentheses in and remind myself that that would be one group, that's helpful in learning how to count by groups. And then I can see that I have a single iron atom and 3 hydroxide groups. Now I should be able to look at and see my atom inventory doesn't match on both sides. So my reaction is not balanced. I have 2 iron atoms on the reactant side. What number do I want to put in front of the FeOH3 on the product side to get it to balance? Hopefully you told me we need a coefficient of 2 here. And when I put that in, I now have 2 Fe atoms, and I have 2 times 3, or 6 hydroxide groups. Okay, Fe is balanced. Now let's look at sulfate. I have 3 groups of sulfate as reactants. I have a single group of sulfate as products. What coefficient can I put in right here that would fix that? Hopefully you told me a 3. And in doing so, 3 times 2 makes 6 potassium atoms. 3 times 1 makes 3 sulfate groups. Note I don't have to multiply that 3 into things inside the parentheses. I'm counting those as a group. I have 3 groups that include 1 sulfur and 4 oxygen. All right, now we have Fe and sulfate balanced. Let's look at potassium. I have 6 potassiums as products and only 1 as reactants. What number do I want to put in front of the KOH that will not only fix the potassium, it will also fix the hydroxide? Hopefully you told me a 6. I will now have 6 potassium atoms and 6 times 1, or 6 hydroxide groups. And since we have an equal number of atoms and an equal number of groups on both sides of the reaction, our reaction is balanced. We can now say that for every 1 iron 3 sulfate, we need 6 moles of potassium hydroxide to produce 3 moles of potassium sulfate and 2 moles of iron 3 hydroxide. Let's look at a second example. I've got aluminum hydroxide reacting with sulfuric acid, H2SO4, to produce aluminum sulfate and water. So when I start, I'm looking for matching groups on both sides. And although I see a hydroxide group here, I don't see one here. I do see a sulfate group here, as well as a sulfate group here. So as I start my inventory, I'm going to be counting how many hydrogens and how many sulfate groups are present on both sides of the reaction. Now I need to go back because I have a hydroxide over here, and I want us to look at water very carefully. H2O. Is there another way we could write that formula that would help us out here? What if I rewrote it as HOH, 1 hydrogen connected to 1 hydroxide group? By doing that, I can count hydroxide as a group. I have a single group. And so when I look at this, I now can count that I have aluminum atoms and hydroxide groups, which I also have aluminum atoms and hydroxide groups on the other side of the reaction. I'm ready to create my atom inventory. So again, a note to yourself, you can always rewrite water as HOH, which will help you if you want to count by groups. So let's get started. I have 2 hydrogen atoms and 1 sulfate group. I have 1 aluminum atom and 3 hydroxide groups. On the other side of the reaction, I have 2 aluminum atoms and 3 sulfate groups, and 1 hydrogen atom and 1 hydroxide group. Now it's time to add coefficients. Let's just work our way down. I can see that I have 2 hydrogens. Over here I have 1. So what number can I put in front of the HOH to fix that? Hopefully you told me you needed a 2 coefficient, which will give me 2 hydrogen atoms and 2 hydroxide groups. Next, we need to look at sulfate. I have 3 sulfates as products. I have a single group as reactants. What number can I put in front of the H2SO4 that will fix my sulfates? Hopefully you told me a 3. 3 times 2 will make 6 hydrogen atoms. 3 times 1 will make 3 sulfate groups. All right. Now we've noticed we fixed sulfate and it's made our hydrogen unbalanced again. Hopefully that rectifies itself as we keep working. I have 2 aluminums as products. I have a single aluminum atom as a reactant. What number should I put in front of this aluminum hydroxide to fix that? Hopefully you set a coefficient of a 2, which will give me 2 aluminum atoms and 2 times 3, or 6 hydroxide groups. We can now see that aluminum and sulfate are balanced, but our hydroxide and hydrogen have become unbalanced. What do we need to trade this 2 out for? What number should we use instead there? hopefully you set as 6, which will give us 6 hydrogen atoms as well as 6 hydroxide groups. And our reaction is balanced. We have the same number of atoms and the same number of groups on both sides of the reaction. We're done. We can say that for every 2 moles of aluminum hydroxide, we need 3 moles of sulfuric acid, H2SO4, to produce 1 mole of aluminum sulfate and 6 moles of water, HOH. Some common mistakes. When you adjust your coefficient, make sure you adjust your atom count for all of the atoms in the formula, the ones that are atoms as well as the groups. And make sure that coefficients multiply into subscripts, as they represent the number of moles or molecules of that compound. Thanks for listening. Have a great day.